Great. So can I start? Perfect. Okay, so welcome to the talk. We will be playing today with the time. So the name of the talk is Strategies for Dealing with the Date and Time in Test and Production Code. So the main point with this talk is that I would like to give you some tools. When you will finish this presentation, you will be able to take it to your source code, to your team, and be able to implement them. So we will try to digest what happens usually with our code when we try to deal with date and time. So who am I? I'm Marek, Dominiak, so I kind of have few years of experience of professional development in Java, Spring, other technologies, and I'm co-owner and instructor at TrainingTech, CTO at SparkBite Solutions, and hands-on architect and tech lead in Mintra. So that's kind about me. So this is essentially a Norwegian company. Some of you may heard about it, but that's enough about me. So we will follow these steps. So first of all, we will show, and just you will probably see date and time, like how do we usually deal with this in your source code. Probably it will be pretty normal code to you, but we will see the consequences of keeping this way and using this in production code. Then we will be switching between production code and how it shapes and influences our date and time in test code and our options, what we can do with this. Then we will see some more complex scenarios, how we would like to deal with them, and we would like to ensure some rules when it comes to date and time in our source code and code base. Then there will be Q&A. So, who of you has experienced any issues with date and time in your career? Like everyone. So, when I started to prepare this talk, I thought, oh, I know like few, maybe 5. So I listed them, but then the list kept growing and growing and growing. And on the 14th point, I identified that I can't show this 14 problems over here because we would spend 10 minutes of the presentation on it. So I moved it behind Q&A, like those things I identified, and I just like gave up on this. It's just impossible to list all of those issues. But we will focus on some really important ones at this very moment. So let's start with how do we create dates in our source code, in our production code. So new date, anyone on Java 8, predating Java 8? Fortunately not, but still, if you are even above Java 8, you can still see new date. So anyone uses or is courageous enough to say that you're still having new dates in the source code? Yeah, okay, courageous, a few hands. Okay, so did you see maybe local date time now, new timestamp? So this is coming from Java SQL or instant.now. Sounds familiar, yes? In the domain code, it's pretty useful. We have some other options. Now, we were hit with some issues with time zones. So then we identified that maybe we should just pass as well zone and time zones to our parameters when we build them. So maybe some of those sounds familiar. Are those familiar to you? Who uses kind of this approach with clock and getting instant? Like not many. And we will be talking about this a lot today. So now, just to make the point and the premise of the whole presentation, we need to just understand this very complicated domain. There are only 3 beings there. It's not domain-driven design presentation, so we will keep it very, very easy. We have a user, a course, and user can be enrolled to a course, and then they can start and complete the course. Very simple. But on a timeline, we will have this kind of, this process will take time. It's kind of like a saga. So user is enrolled. The enrollment can be available not always from the same point in time when someone was enrolled, because maybe you would like to allow and just do like a new course and say Sunday 17, we have this new course, and even though you are enrolled to it, it's available from then. Then user can start this course and enrollment, then complete it again a few days after, and then the completion may be valid until some example 2 days or 2 years. So by the way, the whole source code I'm showing over here is available on GitHub, so we will be able to run tests, see the source code, how it's shaped. So this is our scene for the talk. Now this is a tricky question. So there is code on the left side and on the right side. And now tell me, what is the difference between runs, not the code, the runs of this code on the left and right side? Any guesses? It's tricky, so I will start to answer. So the difference is that they can run at different time. But taking a look at this code, can you see the difference? No. And now let's start and let's take a look at enrollment.start implementation. It's kind of pretty normal code. Enrollment over here is our domain object. It's not any Spring Bean, okay? So this looks pretty awesome. So we just create some instant and we check whether this course is started before, available from, and if it's before, we shouldn't allow it. Like simple logic, invariant, keeping in domain-driven design, yes? However, this part looks innocent, but it's not. It's essentially a Pandora box open here. So what's the problematic thing with this code? This one can show error because it was run on 2023-09-20, and this one works because it was run on 26. Identical code. There is no clue over here for developer or anyone that it can fail. Okay, so this is an issue. Let's go deeper. So we have there is a consequence. The consequence with this, there is a problem that we have a dependence on the system clock. And this is a problem. So the problem is this, that how can we reliably test scenarios in the past and in the future if we can't control time? So now I will show you hacks. Most probably some of you did on, during years of development. So, okay, we need to hack it. So let's hack the domain object. So has any one of you created something like domain object util for set value? We know that it's a reflection, yes? And trying to bypass the rules of the domain and shove the data in the tests to essentially make it work. It's hacking, yes? Do we really test domain logic here if we bypass some rules? Sometimes we are not sure. Maybe okay. Another one, we are writing tests. So this is essentially the real piece of code. I won't tell you who wrote it, unfortunately, but I will point. So essentially wrote this because I needed somehow to show like the passing of the time in the test to essentially test some functionality. So who has written some slips in their test code? Yeah, some of you. By the way, later on when I was looking through source code, I was shocked to see that you can do better. This is much faster, much better, But please don't use it. Don't use it. It's still a hack. Still a hack. We are still in the same millisecond, and we are trying to do some hack. But when I saw, I didn't know whether the developer there was really creative and really intelligent, or was trying to hack even more. But this is again hack. So we hack our code, domain objects. We try to add some sleeps. Later on, we have to do some more. So let's do mocking. Who used Power Mock? Those of you that are old enough remember it. Later on, Mockito from version 3.4.0, they allow mock static. But again, they put in their docs like big disclaimer, please don't use it. Like it most often, you know, it's last resort only. It's probably means that your production code is pretty badly designed. You should take a look at this. But unfortunately, they bend it and they add it, and so now we have to deal with this. Another situations, another solutions. So delete this flickering test. So we have a test that sometimes works, sometimes not, because of the whenever it runs on CI. So the suggestion is let's delete it. Or what's the other option? Let's ignore it, yeah. Let's put it, yeah. Another one, so we can hack domain object, bypass the domain rules. Or who has manually changed the system clock to test some functionality? Only so many, yeah. But anyway, again, those are hacks. So now there are some other problems. So how will you, essentially even with those hacks, will test this whole process if it has to take some real time? You can't, simply. For example, this scenario. An online exam must take no longer than 2 hours. Each question should take minimum 12 seconds, because we don't want, you know, we want to catch hackers. You know, like if someone does it, it's something fishy around that. We need to catch it. So we have 100 questions exam, and it must take minimum 20 minutes. So how will you test it in the code? Without hacking, putting slips for 20 minutes? It's unreasonable, okay? The list goes on. And there are 2 more problems. So violated the principle of least surprise. So look at this. Do you know what to expect? Do you know that there are some magical things going on? Someone creates date and time and just tries to do some calculations? No, because maybe you will discover this. So the problem is this. You got an error, a bug in this code. All right, it's easy. It will take half a day, you say on the stand-up. You go in there and discover that there is like a bunch of things, like enrollment start calls enrollment do start, that calls some service, that calls some policy, that some calls private methods, and eventually on 8th layer of inception, someone creates instant now. So now, have fun with testing and refactoring this code to essentially add regression test. So who had to write regression test for a badly designed code and wanted to go kill yourself and just maybe go and fetch coffee, 2 coffees? You just postpone this task, you don't do that, or you just push on some other people. So we feel this. This is a problem. Time is a dependency in our code. So we need to have control over it. So you should have control over time application-wide, meaning there should be only one place where you really create dates. So how it will look like? We have already this thing, but we don't know how to use it. So we have the clock. By the way, on this part, it can be the clock, date provider, date supplier, anything that wraps creation of dates. However, from Java 8, we have the clock. Why to use another abstraction? There is one very important thing, that clock gives us instant. So instant is always in UTC-0. We always know what it is. And this is all we need. Let's use it. How will you use it? We can take a clock. We can create an instant. We can take a clock from a specific time zone. This one just gives us UTC plus 0. Or we can create a fixed clock, because now we have some abstraction over it. So now we can control the clocks however we want. So the fixed clock is a very fun one. So this clock will always give you this instant. So you can use it in unit tests, for example. We will go and look at all of this. So we need to make the time explicit in the code. So let's take a look. Now, this is a revision of the code that I showed earlier. The only difference is that we introduce clock from somewhere. We'll talk about from somewhere. And now we have enrollment started clock. By the way, who feels on the first glance that it feels a bit ugly? So I felt it. I felt it looks ugly. I don't want to see it. But then the problem is that it's just adaptation phase. It's just habit for us. We thought that it's not a dependency, but it is. And when I started to love it at some point, because you know what to expect from this code. Now you know someone will use it, someone will do some things over there, and now this is explicit. You read it, and someone asks you, how much time, fixing the bug over there will take? Okay, now you can say half a day, and most probably you will be more right than previously because you have no idea. So on the domain object level, it looks like this. We have an explicit parameter, and instant now just receives a clock. And this one will be produced by the clock. Now, who uses Spring? Most of you. This is the whole configuration of production class for Spring. That's it. Profile, not test. Why? Because for tests, we would like to have different ones. The ones we will be able to control differently. But for clock, we can say clock system UTC, which is UTC plus 0. Done. We have a singleton. By the way, I don't like, no one likes singletons. They are not real design patterns. But here, we want application-wide control. It's perfect. That's the whole configuration we need to have. How will we use it? So this is a Spring Bean. It's a service, transactional. We inject a clock and some enrollment repository. Then we have one transactional method. It's just inherited from over here. Start enrollment. From repository, we find our object, and we say enrollment started clock. That's it. That's the whole production code. Now, but this gives us a lot of flexibility. So on enrollment, again, we have a clock, and we use this clock. And this clock is the Spring Bean we just injected somewhere else. Okay? By the way, who has looked at the Oracle documentation, clock documentation shipped with JDK? Yeah, as I expected, I think Oracle documentation is only a tiny bit better than AWS documentation. So who likes AWS documentation? Three people, more than I thought. Essentially, but over here, what's very nice? This is official doc. We have a bean. We have a dependency injection clock, and we should use it somewhere else. This approach allows an alternate clock, such as fixed offset, to be used during testing or any other. So this is essentially Oracle doc saying us that's how you should use it. And who is using this? Usually not many people. That's why we are having this talk. Important notes about production code with Spring. Inject clock only in Spring Beans. Okay? Now, the second thing, domain objects should be giving the clock instance from outside. That's it. This simple rule gives us a ton of flexibility. And now, we are going to show how it influences the tests and our capabilities over there. So we will have two types of tests. So I'm the kind of person that likes to discuss different definitions. So it's not very strange for me to spend 3 hours of time discussing what's the difference between unit, integration test, and just different kind of categorization of tests. For the sake of this presentation, we don't have so much time. We just say, we have fast tests. We don't touch I/O, no disk, no sockets, nothing. It's just like simple, some call them unit tests. And we have slow tests where we touch I/O. In this case, it will be some flavors of integration tests. Spring, okay? Spring as well kind of gives us some, maybe not immediate I/O, but let's call them as well. So we have this differentiation. Now, we will be talking about fast tests. So when we would like to control the clock in the fast tests, it's very easy. We can use clock fixed, where we pass instant and zone. And that's it. Fixed means that this will give you all the time the same instance, okay? Which means it's very stable. It won't move, so it's more deterministic. Another thing, who uses Spock? That's nice, maybe 1/3. Who uses JUnit? Most, like 3/4 maybe. Who writes tests? That's good, that's good. Okay, I should ask about this because I thought I will get a heart attack if I would say less hands. But the thing is that if you use Spock, there is immediately shipped with it mutable clock. We will be talking about this. By the way, when you use JUnit, you can implement your own clock. In the source code, I implemented our mutable clock as an example how you can do this. It's essentially 30 lines of code, very simple thing, just very simple abstraction. But in some situations where you have JUnit and Spock, because for example, we have some projects where we use both. For some certain pieces of code, it's better to use Spock, for some JUnit. So in JUnit configuration, as well, we use mutable clock from the Spock, because it was there. Okay, how will we use it? So this is a trait from Spock. So it's like an abstract class, or you would almost assume a rule from JUnit, that we would like to have some support for messing with the time in fast tests. We will have 3 very important methods. First of all, for each test we create a mutable clock. Then we have an instant, local date and local date time, that will use this clock to produce things in our tests, okay? And then we have 2 options to manipulate the clock. Set clock to an instant. Let's say I would like to go back in time 1st of January 2000. That's it. There's the clock, and we just run our simulations, whatever. Or we can have adjust clock. We would like to move 1 day ahead, 2 days ahead, 30 days ahead. Usually I use this version. Usually this is more used option. Let's take a look at the test using this trait. Enrollment can be started. So we have instant now using the clock. Clock is the mutable clock. And we can adjust it. We say we would like to move 1 day ahead because this course, we would like to be sure that we start it 1 day after, okay? Who likes this code? All the little people? Do you have control? You are still not convinced. Okay, but let's take a look at this. So again, enrollment can be created, started, and then completed during a longer period. So here, I'm talking about this process of moving in time and essentially fulfilling and testing my domain code without any hacking, without any slips. So we have a clock at some point. We say that enrollment is available from 14 days ahead. No hacking needed. We just adjust clock. We say 30 days has passed. We start enrollment. We adjust clock another 7 days, and then we complete it. And that's it. With this first implementation without clock, how would you write this code? How would you write this test? Impossible. That's it. You will just do hacking, which is never a good sign. Now, another beautiful thing about mutable clock. So tell me what happens here. It will be green or red? Red. Okay, why? There are 2 different times. Okay. It depends on how fast your machine is. Because instant is much better than date because it counts nanoseconds. So obviously what happens is that those nanoseconds over there change, so this will never be the same. However, when you write your code, you create 2 dates apart, they look identical in the code, but then you have a run of it, and now depending on how fast your computer is, maybe your CI is slower, or maybe we improved our CI and it's much faster, and now it doesn't pass. you don't have deterministicity in this code. But one thing, one adjustment, you pass it mutable clock there, then it always passes. So you have deterministicity in your fast tests. So mutable clock is awesome because it is fixed unless you adjust or change it by yourself. So essentially now you have complete control over time and you can do wonders with your domain object without hacking them or sleeping in time. So those are fast tests. Now, I had it, because of the name of the presentation, I had to like link it together with this awesome movie. By the way, I watched this like a month ago. It's still good. It's still good. Who likes this movie? Yeah, okay. This is essentially Back to the Future. We just now, with this clock, we can move Marty and Doc through the whole movie in one unit test. And it runs. But now you say, okay, Marek, but this is unit test, it's easy. What about Spring? So let's talk about slow tests, okay? Again, in slow tests, if you would like to control time, we can use clock fixed. You can use it when you don't care about instance or dates, okay? So just set it, forget it, that's it. Again, if you use POC, you can use mutable clock. The same thing about JUnit. You can implement your own. Unfortunately, I didn't find on GitHub any useful mutable clock implementation that you can use for JUnit out of the box. There are few implementations with very few stars on GitHub. I'm really surprised that JUnit doesn't ship it. But again, we can use mutable clock if you have both of them on class path, even in JUnit. Keep in mind that slow tests work a tiny bit differently. Because now, if you are aware that Spring has an application context for tests, so to make your tests fast or not too slow in Spring, you should reuse your application contexts, correct? So if you reuse your application context, it means it's built and there is a clock over there, one singleton. So now, because we are messing with this in our code, the clock can be maybe, 1 year ahead, 2 hours back, and so on. It's really not that much what you can do. However, what you need to do, you need to take care of the clock between tests. You should clean them or reset. It will work without, but it gives you more sanity if you just reset it and make sure that maybe all tests should start like a current system time, or maybe some specific date you like, maybe the birthday of your daughter. Okay. Configuration for tests with Spring. We have a configuration class, test class config. It's located in the test code. It's a bin, and we just provide a clock implementation, mutable clock, with some UTC zone ID. It's a singleton. So now, all the application, all the tests in the Spring application will be able to use this clock. And because it's mutable clock, it gives us options. So now, our Spring Boot test, this is JUnit now, we'll have auto-wired mutable clock. Why do we inject mutable clock and not clock? Because we want to move it. We want to adjust it. So now we can say, we want clock to set to instance, to enrolled at, and enrolled day at is just 1 month ago. Now, we can say that handler.start enrollment get ID this is something where handler, you see, there is no clock over here. Yes? We don't pass any parameter here. Why? Because the handler inside is another Spring bin that has injected its own dependencies together with the clock. We just manipulate over here. So it gives us a control. We can manipulate the Spring bin outside thanks to the mutable clock. Another test, this one is like happy path. This one was unhappy path where we couldn't start enrollment too early. This one is where we can start enrollment because we moved 2 days ahead into the future. So we set the clock at 11th of September 2023. Then we move to the future by 2 days. Then we start handler with enrollment. We saw the implementation of it. There is injected clock, and the clock will produce instant that is after available to date, available from, and it passes. It's a integration test. So let's see the trait for integration tests. So the trait for integration test is almost identical as for for fast tests. However, there is a notable difference that here we have an outwired mutable clock. And why is it so? Because it's a Spring Bean. We need to inject it. Over here, there is this very important thing. The source code is provided on GitHub. This mutable clock test execution listener just resets the clock to the current system time. So for each start of the test, we kind of start with the clock resetted at currently here. So this listener is, I guess, many of you who had to create some test execution listeners, for example, for cleaning database, Elasticsearch, or anything else. So Spring heavily uses this option to do this. We just build another extension. That's it. Now, we can back to the future in integration tests. Beautiful. Again, identical output. We have a test that has auto-wired bean, and this bean will just use the clock to show some output. And again, we move exactly like we did in the movie. Integration test. Who likes it? Do you think you can test more with this? I for sure. Okay. So we will show a couple of more things. I will show a couple of more things. So slow tests. We need to clean up before after each test. So we can use it with before each, obviously, resetting the clock, or we can create a test execution listener to do this. It's very simple. Now the question is, but Marek, my fellow developers won't use it. They will still put the instant.now in the source code. So who is worrying about this? That you won't be able to force it as little people. Okay, so there is, there was one presentation showing this tool. I think maybe even 2 or 3 mentioning, but there is a special tool that gives you a nice power. And there it is that you can write and use ArchUnit. So if we'll read you with me, this is a JUnit test. Check that clock is used to create date in production code. No classes should call method local date now without passing clock, or the last one is the best one, or should call constructor date. Now, more beautiful thing is over here. In production code, we use clock to create dates, and here you put a link on the wiki explaining why. So now, before you will get to code review with 2,000 lines of code where you are overloaded with other work and you won't see this instant.now, it won't happen because the test will be run or fail on Jenkins, and you just, before doing a code review, you just say, okay, go and fix and test, and there was a link to the wiki. So thanks to this, this is a first step where you can start to change the code in your current code base. So you can use it. You don't have to fail it immediately. You can check how many violations are there, and you can slowly change, refactor code, and replace usages of date, instant, and other things to essentially to have something, especially in your domain code, that allows you to have control over time. I didn't know what to put over there, but I think it's so beautiful. By the way, there is option of using ArchUnit for many other things, but ArchUnit could cover probably 1 track of presentation for the whole like conference. So you should just use it. Okay, but that's not all. By the way, who uses ArchUnit? Okay, more and more people. That's nice. So who has rules like this? All right, 5 people, that's nice. This will save you a ton of time. I can't stress it enough. Okay, now let's talk about another thing. So what if you have some slow test, but now you have a more complicated scenario? So you have to essentially wait until something happens somewhere else. So let's talk about this scenario. So we have one integration test over here, and we have some payment or invoice finalization with the payment provider, okay? So who had to write integration tests where you had to, for example, wait for something like Elasticsearch documents or maybe Stripe callback or some any kind of external payment provider? So many of you at some point will have this kind of code. And the reason for it is that if you will mock it, you are not sure whether it works because the API of it can change overnight. Or maybe it was sent by a provider 6 months ahead to CTO, but CTO didn't have time to read the document, and now he tells us that, you know, like, all right, API has changed, you need to change it overnight. We will catch it in the tests. That's nice, you know. So the whole idea over here is that we are running some calls somewhere, and this thing we don't have control of. So now we need to asynchronously, something will happen, and we need to deal with this. So for this, obviously you know what the answer is. Can someone say it? What tool will you use for such cases? Await utility. It's a very small tool. Again, it was said this is an excerpt from the real code where we had to wait for something asynchronous happen somewhere. So we had a wait at most 1 minute with a 1 second poll interval until asserted verified invoice can be downloaded and has proper contents. So essentially we treat it like a black box, and we knew that at some point in the future something will be available somewhere, and we are just awaiting that this happens, and we can download it, we can unpack it, we can check whether the customer name is fine, whether the, you know, like what we calculated on this invoice should be, and so on. So because we did this, the clock doesn't help us much here, because we are not in control of this code. This is essentially real integration with something else. So another example is a testing against Elasticsearch. So Elasticsearch is a beautiful thing, yes? However, it's really good for searching documents. It can lose documents, you know that, because it's just a search engine. However, there is not like a nice mock replacement for tests. So usually in integration tests, you need to spin up the whole Elasticsearch locally. Or if you're on AWS, you will have to integrate with OpenSearch and run tests against this. You don't have control over one or the other. So we need to do those things. So we should use await utility when you have to wait for results of an async operation that is outside our control. When integrating with, for example, payment providers, SMTP servers, Elasticsearch, obviously messaging systems, yes? Anything asynchronous that is outside our control. So that's kind of like, that's it. By the way, at the beginning of the, when I started to prepare it for this presentation, I had like 1 more hour of material, but it was just impossible to fit it into one. So probably I will do another one on dealing with time zones and other things. You will find few slides that's available on the GitHub with some tips and tricks. One thing before we go, and I will just give you option to ask questions, I would like to show you the running Arch unit. So just to convince you that we should use it. Like this code I showed is a real code, which I tried to violate by creating a class that some junior or someone or a senior just created. We banned using new date. Now we run our test that says, we run our test if I will find it. And we can read how nice it is. So now we have a violation, architecture violation, saying that priority medium rule no classes should call some constructors, for example, instant now, is violated. Okay. By the way, why I wanted to show it to you? Was it quick? It's a unit test. It's not like a big thing. It just runs instantaneously. Feedback loop for newer developers in the team is really quick. And we can fix it by just going to our class, removing it. Just we commented out this code, we run it, and it's green. Okay, so remember, time is dependency in your code. Take a good care of it. The GitHub code over there, Back to the Future, there is a LinkedIn if someone wants. And that's it. So I think we still have 4 minutes. I can have some questions. I will be as well here for a few minutes afterwards if you would like to ask some specific questions. Any questions?